Alright, the last video for Chapter 8's review focuses on 8.6, where we're now going to focus on the equations and equality standard. I'm not going to focus too much on the models and structures since we did this class before, and you have a lot of examples to prove it, but this is your cornerstone to be able to do the models and structures. You need to be able to solve the equation and make sure we state the excluded values. So I'm going to go ahead and state the excluded values right now. So my excluded values are b cannot equal 1 because it makes this denominator 0, and then b can also not equal -1, which means after solving this, if any of my two answers come out to be those answers will not work, and we can cross one of those out. So this is kind of going back to the whole adding and subtracting rational functions. We need to find our LCD for all denominators. So right now this one's over 1, so we have b plus 1, b minus 1, and a denominator of 1. So my LCD then is b minus 1, b plus 1. Don't need to worry about the denominator here of 1 because that's 1 times anything, it's just itself. I will say let's cross the line, change the sign just to make sure that we know that those are negatives in that expression. So what I'm going to do then is I'm going to take this whole expression and I'm going to multiply every single fraction by my LCD. So I'm going to take 3b minus 2 and I'm going to multiply it by b minus 1, b plus 1, and put it all over b plus 1. That's my first expression. Is then equal to 4 times b minus 1, b plus 1, all over 1. Notice we're only multiplying the numerators. Our goal is to cancel out the denominators using the clearing method. So we got plus a negative b minus 2, b minus 1, b plus 1, all over b minus 1. Boy, I started with a long problem first, didn't I? So now we're going to go ahead and start canceling. So you see that the b plus 1s are going to cancel, the b plus 1s are going to cancel, leaving you 3b minus 2 and a b minus 1 is then equal to, nothing's going to cancel there, so 4 times b minus 1, b plus 1. Plus, the b minus 1 here is going to cancel, the b minus 1 here is going to cancel, and we're left with negative b minus 2 times b plus 1. So we have all of the denominators are now gone, creating a nice linear, or in this case it's going to turn out to be a quadratic function that we might have to solve, or might have to use quadratic formula, completing the square, or factoring. But first let's just find out what happens. So we need to simplify this. This simplifies to 3b squared minus 5b plus 2. After we did first times first, outer, inner, last. Is then equal to 4 times b squared minus 1. So we're going to go 3b squared minus 5b plus 2 is then equal to 4b squared minus 4. And that's this whole thing FOILed together, distributed to 4. Plus a negative b squared, a negative b plus a negative 2b, which is then negative 3b, and a negative 2 times 1 is then the negative 2. So I'll just copy that down here. Now our goal, as soon as you see a quadratic, is just to see if we can simplify. So 4b minus 1b becomes 3b squared, negative 4 minus 2. So we have negative 3b minus 6 is then equal to 3b squared minus 5b plus 2. So notice this is just a lot of algebra, manipulating the variables. The nice thing about it is that these are going to end up canceling because you're going to subtract each other, cancel those out. Well, We'll add 5, or actually let's just add 3b. We get negative 2b. We subtract 2 here, we get negative 8, and then negative 8 divided by negative 2. B is then equal to 4. This is my solution that after I did the clearing method, the LCD left me with the answer B plus 4. The only answer that makes this rational function here, this rational equation, equal to this expression. And the only thing we got to double check is make sure that this answer does not match our excluded values. And since this is not the same as that, we're done. This is our nice, good answer. And I know there's a lot of foiling here, but that's the expectation we need to make sure we take care of and watch the negative. If we didn't distribute the negative, this b, this 4b squared, and this negative b squared here would not have canceled very nicely. We would have to get to a factoring situation. So in this case, the b squareds end up canceling, leaving us with a linear expression and a linear answer. So we got one solution coming out. So the reason I want to give you one of these is I don't think I have one of these on your homework where I just give you the coefficient or just a constant number. Always put it over 1 so you can find your common denominator. Let's go ahead and do another one. So this one's a little bit bigger here. So the first thing we want to do is we want to take care of anything that's the bottom. We need to find our factors. So factors of 12 that add to 7. So p plus 3, p plus 4. So my LCD in this problem then, we have a p plus 3 and we have a p plus 4. That would be my common denominator for all the expressions. So I'm going to multiply everything by that. So if I multiply every single thing, 1, 2, 3, noticing here p plus 4, or p plus 4 and p plus 3 is the denominator, that ends up canceling with the LCD, so we get 12p plus 19 is the only thing left over. Oops. Let's just cut. We'll just start over. Sorry about that. So because this cancels and that cancels and this cancels and this cancels, in this expression here, we're left with 12p plus 19 minus the p plus 3 is going to cancel, the p plus 3 is going to cancel, leaving us a negative. Across the line, change the sign, so we'll make this a negative 3 times the quantity p plus 4 is then equal to. So our goal was to get rid of the p plus 3, get rid of the p plus 3, which has ended up what happening here. So we cross out the denominator. We cross out the p plus 4s, we cross out the p plus 4s, and you get 5 times the quantity p plus 3. So we get 12p plus 19 minus 3p minus 12, which is then equal to 5p plus 15. To do a little simplifying, so the 12 minus 3 is 9. And then, so we get 9p plus 7 is equal to 5p plus 15. 4p is then equal to 8, so then p is equal to 2. And the last thing we want to worry about is making sure that our excluded values for p was that p could not equal negative 4 and p could not equal negative 3. And looking at this scenario here, as long as this answer is not the same as those two, this answer works. So therefore, our answer would then be p equals 2. So I'm hoping this thing is starting to follow through, kind of laying for you. The one thing I'm going to walk through a little bit more of is an inequality one. So let's just make up one here. Let's say if it was 3 plus, let's say 2 over 4x is greater than 3 over, let's say 4. Actually, let's just make that. Let's make it. Let's make this x. So the similar question is that we want to multiply this whole thing then by my LCD of 4x. So the common denominator between all of them is 4x. So I'm going to get 12x out front here. I'm going to get 8x divided by 4x, which is then going to cross out to be 2, is greater than 12. So we're going to subtract 2 and get 12x is greater than 10. X is then greater than 5, 6. Now the reason I'm doing this is that the process does not change when it's an inequality. The only difference is that now we have a number line that we have to analyze to make sure that does these values work, yes or no. So currently we have 5, 6 with an open dot right here, and we know in our mind that the values that are greater than 5, 6 are going to make this statement true. But we need to keep in mind that our excluded values for this one, x was not equal to 0. Because I can't plug 0 in and get an answer out. So I have to include that in this situation. So we have an open dot at 0, and now I need to pick values that are less than 0 and plug it in here. So let's say we plug in -1. And then we need to pick one value that's greater than 0, and let's say we plug in 1. So when we plug -1 in here, you get 3 plus 2 over -4 is greater than -3. So 3 plus a half plus a -1/2 is 2.5, so it is 2.5 greater than -3. Therefore, you say yes. When we plug 1 in here, we get 3 plus 2 over 4 is greater than 3. So 3 plus 1/2 is 3.5. Is 3.5 greater than 3? Oh shoot, I'm sorry. Sorry, I made a mistake here. We're supposed to pick values that are greater than 0 but less than 5, 6. So I couldn't pick 1. So if I plug a half in here, we get 3 plus 2 divided by 2, which is greater than 3 divided by a half. So 3 divided by a half is 6, greater than 4. 2 divided by 2 is 1. 1 plus 3 is 4. So it's 4 greater than 6. We say no. So because you say yes, that means that if I plug any value that is less than 0, I'm going to get a true statement. But if I plug anything between 0 and 5, 6, my answer is going to be no, as we just found out here. So we make sure that when you say yes, it's going to go that direction. So my solution to this problem is going to be x is going to have to be greater than 5, 6, or x has to be less than 0. So you're checking the interval that's below your excluded value, between the two, the answer you found in 0 and greater than 5, 6. But if you've already found this value, we know that that statement is true because you solved that equation. So we know the arrow is going that direction. If I had 2 excluded values, let's say we had some reason we couldn't have it equal to 1, then we have another open dot on 1, and we check below 0, between 0 and 5, 6, between 5, 6 and 1, and then greater than 1. But in this case, we didn't have to worry about that. So you solve it, that's always going to be one of your restrictions. You need to check the intervals because that means any of these values that makes this statement true will give me a true statement to say that this left side is greater than the right side. Alright, that wraps up chapter 8 review. The only other thing that's obviously on your test is your models and structures, which is the last page of 8.6, which we're going to give you some analyzation and some process on that. Some feedback for sure. We're going to do a lot of in-class stuff on Wednesday, or like we did on Wednesday. So if you ever have questions, feel free to email me, contact me, let me know. We do have enrichment on the Tuesday. You just have to come get a pass from me, and as of right now, I will be there on that Tuesday. So I will see you guys then.